Hello everyone. Shall I now discuss about the topic laser? Lecture 4 Explain the carbon dioxide gas laser. Now presented by Dr. P. Saritha, Assistant Professor, Department of Physics, Government College of Engineering, Tanjavur. Carbon dioxide gas molecular laser, that is 4-level laser. It was developed by Indian born American scientist Professor C.K.N. Patel. This laser transition takes place between the three vibrational energy states of carbon dioxide molecule. It is a very efficient laser. This laser, there are three important characteristics are given. First one, active medium, mixing of carbon dioxide, nitrogen and helium gases. That is considered the active center. Second one, pumping process, electrical discharge method are using. Third one, laser output wavelength 9.6 micrometer and 10.6 micrometer laser sources are produced. Three vibrational spectra of carbon dioxide molecule. First one, symmetric stretching mode of vibration. Carbon atom at the center with oxygen atoms are attached. One at each sides. Carbon atom is at rest. Both oxygen atoms are vibrate. They are moving away along the axis of the molecule. Second one, asymmetric stretching mode of vibration. Both oxygen atoms and carbon atoms vibrate, move in one direction. Oxygen atom move in one direction and both carbon atoms are vibrate in opposite directions. Both oxygen atoms and carbon atom vibrate asymmetrically. And third one, bending mode of vibration. Carbon atoms and both oxygen atoms vibrate perpendicular to molecular axis. This diagram for carbon dioxide gas laser. Construction of the CO2 laser. First we go to consider this active medium or active center. Three molecules are given: helium, nitrogen and carbon dioxide molecules inside the optical discharge tube. This quartz discharge tube 5 meter long and 2.5 centimeter of diameter. This discharge tube is filled with the gas mixing of carbon dioxide, nitrogen and helium. With suitable partial pressure values are given. For example, 0.33 and then 1.2 millimeters are inside the gas molecules. Fill up this discharge tube. The terminal of the discharge tube are connected to DC power supply. The ends of the tubes, both end for attached this sodium chloride brewster window. This sodium chloride brewster window, this optically polarized light sources are emitted. This at top of the surface, this exhausts this vacuum. Some of the pressures for exited, and both side for two optical resonator, for one fully reflecting mirror and another one partially reflecting mirror. This partially reflecting mirror pathway only without using the laser beams are produced. Construction and working principle of CO2 laser. The laser transition takes place between the vibrational energy of the CO2 molecules. The optical resonator is formed with two concave mirrors. One fully reflecting mirror M1 and another one for partially reflecting mirror M2. Your laser light source for only emitted using partially reflecting mirror. And this diagram explain this for construction and working principle of a CO2 laser. The population inversion is achieved timing. These laser beams are producing. First we go to starting the DC power supply switched on. The excitation by the electrons inside this quartz discharge tube, the mixing of gas molecules for ground state level to the exit state level. First, this nitrogen atoms, one electron absorbed after go to the nitrogen, go to the exit state energy level, and some of the electrons returns to the ground state energy level. And nitrogen atoms and transition between the carbon dioxide molecules. Carbon dioxide molecules go to the exit state energy level and some of the nitrogen atoms returns to the ground state energy level. This pumping process for electrical discharge method. Okay, this inelastic collision between the two atoms, nitrogen and carbon dioxide molecules, inside this transition between this exit state energy level. This carbon dioxide molecules are for three modes of vibrations are given: asymmetric, symmetric and static bending mode of vibrations are given. This inelastic collision between the two atoms, the carbon dioxide molecules are for absorb the nitrogen atoms. This nitrogen molecules are for returns to the ground state and CO2 molecules were presented in this exit state energy level. The CO2 atoms are presented by the sum of the time 8 seconds only. The exit state level to the metastable, this is a transition timing. This population inversion is achieved. The carbon dioxide molecules at the metastables are for return timing. Two laser beams are emitted, one for 9.6 micrometer wavelength, another one for 10.6 micrometer wavelength. The transition between these two kinds of laser, one is a form of 001 level to 020 level. These laser beams are producing 9.6 micrometer. And another kinds of transition takes place 001 and 100. These laser beams of wavelength 10.6 micrometer laser beams are producing. This metastable and remaining nitrogen molecules are for spontaneous emission process occur. These molecules are returned to this E2 level and then E2 to E1 level without non-radiative decay, without no changes, and automatically return to these nitrogen molecules. The exit state level to metastable level only where population inversion and simulated emission process are occur. The laser principle producing in this exit state level to the metastable. This is a partially reflecting mirror using this laser beams are emitted. These are two type of laser beams are producing 9.6 and 10.6 micrometer wavelength. This was diagram CO2 level. It's a medical field. The CO2 laser are analyzed, and then this was CO2 laser. This is communication purposes. Your optical signal long haul and short haul communication process are using. And applications of CO2 laser: neurosurgery. This is a major medical field. It's a brain tumor, or cancer cell treatment, blood cell treatment using CO2 laser, open air communication, satellite communication process, astrophysics relevant, can all data are analyzed using CO2 laser. And major applications of military weapons, the enemies are killed using laser source, laser gun, laser weapons, and then industrial field, welding, drilling, cutting, soldering, etc. The material processing and the surface, smooth surfaces of the material preparation using laser, carbon dioxide laser source. This remote sensing material are used. Treatment of liver and kidney and lung diseases, releasing purposes using CO2 laser, and general surgery using CO2 laser also. And accident timing were exposure many damage eyes. Sir, high power laser light source. Sir, invisible the laser light source. This were suddenly affected to our eyes. So very high efficiency of the light source. The high power output. The power is increased by increasing the length of the discharge tube. The discharge tube diameter and width for increasing our output, CO2 laser wavelength is also increasing. So continuous CO2 laser beam, so continuous waveform, the wavelength of the output 9.6 micrometer and 10.6 micrometer. The power output value 10 kilowatt. Okay, these were major applications for medical field. Thank you one and all.